Polyphenol are one of the most fascinating groups of compounds in nutritional research, and their potential effects on NAD+ metabolism represent an emerging area of scientific interest. These are plant compounds that give many fruits, vegetables, and beverages their distinctive colors and flavors. We're talking about the compounds in blueberries, the catechins in green tea, the resveratrol in grapes, the curcumin in turmeric, and thousands of other structurally diverse molecules that plants produce as part of their own defense systems. What makes polyphenol interesting in the context of NAD+ is that they appear to influence multiple aspects of cellular metabolism. Some polyphenol can activate sirtuins, which are a family of proteins that regulate cellular stress resistance and longevity. Sirtuins require NAD+ to function, so you might think compounds that activate sirtuins would drain NAD+, but the relationship is more complex. By improving cellular efficiency and reducing damage, sirtuin activation might actually help preserve NAD+ in the long run by reducing the need for emergency repair responses. Other polyphenol appear to inhibit CD38, the enzyme I mentioned earlier that degrades NAD+ at high rates during inflammation. If a dietary compound could partially inhibit CD38 activity, it could theoretically help preserve NAD+ levels. There's some laboratory evidence that certain polyphenol, including apigenin found in parsley and chamomile, and quercetin found in onions and apples, can inhibit CD38. But we need to be very careful about extrapolating from test tube studies to human brains. The blood-brain barrier issue comes up again here. Many polyphenol are poorly absorbed from the gut, and even those that are absorbed are extensively metabolized by the liver before entering circulation. What reaches the bloodstream is often not the same compound that was in the food, and the concentrations achieved are typically much lower than what researchers use in cell culture experiments. Some polyphenol do reach the brain, but whether they reach high enough concentrations to meaningfully affect NAD+ metabolism is an open question. There's also considerable variation in how different people metabolize polyphenol, which depends partly on gut bacteria. Your microbiome breaks down many polyphenol into smaller metabolites, some of which may actually be more bioactive than the original compound. This means two people eating the same polyphenol-rich food might get very different biological effects depending on their gut bacterial composition. This individual variation makes it difficult to make blanket recommendations about polyphenol intake for brain health. Despite these uncertainties, the epidemiological evidence linking polyphenol-rich diets to better cognitive outcomes is fairly consistent. People who consume more berries, tea, cocoa, and other polyphenol sources tend to have lower rates of cognitive decline. Whether NAD+ preservation is part of the explanation remains speculative, but it's a plausible contributing mechanism among many others these compounds likely affect. Here's where expectations need to be carefully managed. The polyphenol content of foods is highly variable depending on growing conditions, storage, and preparation. A blueberry grown in one region might have 3 times the polyphenol content of one grown elsewhere. Cooking can destroy some polyphenol while making others more bioavailable. There's no standardized dose, no clear threshold for benefit, and no certainty about which specific polyphenol matter most for brain health. The other reality is that in animal studies where researchers find dramatic benefits from polyphenol, they're often using purified compounds given in doses far higher than you could achieve by eating the food. When those same compounds move into human trials, the effects tend to be much more modest or even absent. This doesn't mean polyphenol-rich foods aren't beneficial. It just means the benefits are probably subtle and require long-term consumption to manifest, not dramatic and immediate. So where does this leave us? Polyphenol-rich foods are nutritious, they're associated with better health outcomes across multiple domains, and they have plausible mechanisms for supporting NAD+ metabolism. But we should be skeptical of claims that specific polyphenol or foods are going to dramatically boost brain NAD+ levels or reverse cognitive decline. The reality is likely more modest. These foods may contribute to a metabolic environment that supports healthier NAD+ balance over time, as part of an overall dietary pattern, not as isolated interventions.